Okay, now what you see from here over up to the orange writing is a bunch of physics, okay? Including a little physics of somebody who came in and asked me a question related to his martial arts class. Well, my class is working on something. And it involved the impulse momentum theorem. That's kind of interesting. But if you're not in the physics class, you don't need to worry about any of that. You have to take their word for it, and they're still working to understand exactly why it is. But you have to take their word for it, because they're very close to getting this. You have to take their word for it that all this energy consideration and everything leads us to the conclusion that depth y is a quadratic function of time. Y equals at squared plus bt plus c. So what we are doing is we're going to analyze this data. Now, in the pre-calculus class, of course, we don't have the means of doing an analysis of all 5 data points, okay? And linear algebra class does, but that's their problem, and we'll address that with them as we move through the rest of the term. But it's not your problem. Okay? Your problem is to simply analyze the data that other groups get. So you analyze the data as follows. You sketch a graph on good graph paper, and I'll supply you with good graph paper, and you sketch a smooth curve that fits the data points. Now I'll talk a little bit about how we do that. And then you pick 3 points on the curve. This thing you can't read here says pick 3 points on the curve. Not 3 data points. Your data points have uncertainties and errors, but 3 points on your curve, because your curve is going to smooth out those data points. Okay, and those 3 points will each have a y-coordinate and a t-coordinate, as you know, and we're going to plug those into this formula. Okay, this quadratic function, this form of a quadratic function, and we're going to be able to get 3 equations which we solve for A, B, and C. And we're doing fine with being able to solve the equations. Now, to get the 3 points, okay, what we've done so far is I've had different people analyze this based on 3 selected points out of the 5 points that you had. And usually the models match up pretty well, but you're only using 3 points. And a different selection of 3 points will give us a slightly different slightly different model. So what we are going to actually do, it'll look something like this. You're going to have your graph, and you're going to plot your data. Now when I say sketch a graph, you're going to sketch a graph based on five data points. Okay, and that graph isn't going to be able to go through all 5 points, because your 5 points are going to basically follow, if this is a parabola, they're basically going to follow a nice parabolic curve. But the points aren't going to lie exactly on the curve, because we're a little uncertain. We're counting only to the nearest second or so, and we're never quite sure we really have the mark on the line. So we have uncertainties. So some points will be above the actual curve, some points will be maybe below the actual curve. We don't try to draw a line, a smooth curve through all the points, because if we did that with the points I've indicated here, our curve would look something like this, okay? And we kind of know that the lower the water gets, the slower it goes, okay? And what we're seeing here is it's gone down pretty fast, and then it slows down and almost stops, and then it gets faster again. The curve doesn't do that. The curve is a nice, smooth quadratic. So we don't attempt to even hit our data points. As a matter of fact, if we actually hit a data point, it's an accident. We try to get the trend of the data points, and we try to draw the best curve we can that comes as close as possible on the average to our data points, without wobbling around to try to hit the data points because that throws everything off. It's not a smooth curve. You're not going to be able to interpret the slopes, as we will, and other characteristics of the curve. So your next task will be sketch the 5 data points and draw a curve that you think shows you what's actually going on with the function, okay? And I took this curve a little too far to the left, but that might be the smooth curve that best fits these data points. Then we're going to pick 3 points. Not this point, this point, this point, this point, or this point, not our data points, but 3 representative points on our graph that we think pretty well reflect the overall trend. And we don't want to pick 3 points from just one section of the graph. We want to spread them out. We don't necessarily have to pick the starting point and the ending point, but we do 3 representative points. So we're going to have a y and a t here, we're going to have a y and a t here, we're going to have a y and a t here. So we get our 3 equations. And we solve to get our A, B, and C in the manner that we've learned.